Welcome Algebra 2. This video is on graphing an exponential function. The essential question is, how do you graph an exponential function? Let's begin. Let's start off with some examples of what an exponential function looks like. So right here I have 4 different examples and the corresponding equations. One thing to note with an exponential function is one of these sides will always go up or go down forever. Notice the 2 equations on the left, this one's going to go down forever really fast. So it starts off slowly, and then as we're going to the right and x is increasing, the x is going down really fast, and this function is going up really fast. And then in the other direction, it's going smaller and smaller and smaller, but it's getting closer and closer. It's hard to tell, but it's actually approaching the x-axis, but it'll never actually touch the x-axis. It just gets closer and closer. And it's kind of the opposite with this one. This one starts off really high, but then goes down really quick, and then when you get to x's positive numbers, it's getting closer and closer to the x-axis, but never crossing. Same thing over here, starting really negative and then getting close to the x-axis. So that's the kind of shape you should expect for exponential functions. We call this like exponential growth or decay, and we'll get to that. So some properties of exponential functions, and this is a new word, asymptote. What is an asymptote? Well, it's an imaginary line that the function approaches but never touches. Like I said, that this graph was getting closer and closer to the x-axis, but it never actually touches that. So we have an asymptote, and we draw just a dotted line like this. It's an imaginary line that it gets closer and closer to, but it never touches. And the equation of that line in this case is y equals 0. So you can actually write a line, you can write the equation of it, and understanding what an asymptote is an important part for exponential functions. And we still have properties like the x-intercept sometimes and y-intercepts, and we want to know which direction it's going, positive and negative. But that's kind of the key part there, the asymptote. 2 different types of exponential functions, exponential growth and decay. So growth is when, as the x value increases, the y increases, we call it exponentially. So as you get x bigger, in this case, the y value is going to shoot up quicker and quicker and quicker, so it's just going to go really high. Decay is when, as your x value goes up, it's getting smaller and smaller, so that's exponential growth and decay. Let's compare a graph of an equation to a table. So right here on the left, I have the graph of y equals 2 to the x power. If we actually plugged in values for x, what are the y values? Well, x is negative. Let's start off with 0. 0 is easy to identify. X to the 2 to the 0 power is going to be right here at 1. Y is going to be 1. And when x is 1, y is 2. When x is 2, y is 4. And when x is 3, y is going to be 8. Now, it might be a little, you can't see from this graph. It's kind of harder to see those things. But if you plugged negative 1 for x into the equation, you get 2 to the negative 1 power. And we did our properties of exponents. That's going to be 1/2 or 0.5. If you did 2 to the negative 2 power, that's going to be 1 over 2 squared, which is 4, which is 0.25. And if you did 3 to the negative 3 power, you get 1/8, which is going to be 0.125. So as you can see, this value starts off at 8, like really high when you're over on the x's positive side, but it decreases and it gets smaller and smaller and smaller, but it's getting closer and closer to y equals 0, but never actually touching y equals 0, because that's the asymptote. So it gets smaller and smaller. What's an exponential function look like? What's a general form? Well, here you go. Y equals a times b to the x power. Notice if you follow order of the operations, it's b to the x power. That a is not going to the x power as well. Only it's a coefficient to the b to the x power. And here's some rules. You can't have a b less than 0, and you can't have b equal to 1, and a can't equal to 0, and x must be real. But the most important part is this function here. And here's some examples. Y equals 2 times 3 to the x, 2 to the x, which we just did, or even negative 1/2 to the x. Notice the negatives outside. This is like negative 1 times 1/2 to the x power. The key for all these things, equations, to make them an exponential, x is in the exponent. So it's not 2 times x, it's 2 to the x power. It's a small x up here. So that's what you should be looking for. Let's try to graph a different exponential function. This is negative 2x, which is the same thing as negative 1 times 2 to the x power. So it's going to be a little bit similar. So if we had x negative 2 to the negative 3 power, this is going to be negative 1 over 8. And so that's going to plot right here, and negative 1/8 is going to be really close, but just really close to that x-axis. If you plugged in negative 2, you get negative 2 to the negative 2 power, which would be negative 1 over 4. So it's going to be close, but not quite as close. I'll draw another dot there. Negative 2 to the negative 1 power will be negative 1 over 2. So 1/2, okay, so we're splitting that between 0 and negative 1. When you have 0, you'll have negative 2 to the 0 power. 2 to the 0 power is 1, so that's negative 1. And I can go right here. I'll start labeling some of these points. I'm going to label that 0, negative 1. And then moving on from that, negative 2 to the 1 power is just going to be negative 2. So I'm going to put a plot right here. We'll go negative 1, negative 2. And negative 2 squared is going to be negative 4. So negative 2, it's going to be 2, negative 4. And this will be negative 2 cubed will be negative 8. So that's going to plot right here. Notice when you're graphing this, you'll start seeing where the asymptote should be. You'll see that as I go to the left, this is approaching that line but not crossing. So I'm going to draw my asymptote whenever I want to graph this. It should be right on this axis. Hopefully you can draw a little bit straighter than I can. And then I'm going to put arrows right there, indicate that's the asymptote. And I'm going to draw, just kind of sketch that curve. Now I don't expect you to be a perfect artist, but one thing you want to make sure is you don't cross that asymptote. You cross through all the points, and you don't cross the asymptote. So that's close enough. You just make sure you're not crossing through that asymptote because you're graphing something else. Make sure you don't turn it into a parabola and make the U shape. All right, another thing about this, we can identify exponential functions from a table. So here's a table without the graph, and I'm going to tell you this is the function of y equals 2 to the x. We've seen that a few times already. The way to identify from a table is all the y values have a common ratio. Common ratio means you multiply by the same number for every step. So in the case of linears, you were adding. This time you're multiplying. What's happening here is I'm multiplying by 2 every time. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. Even over here, 1/4 times 2 is 1/2. 1/2 times 2 is going to be 1. So every time x increases by 1, plus 1, plus 1, plus 1, you're multiplying times 2. This, as long as you're always multiplying by the same number, our common ratio here is going to equal 2. That means we have an exponential function. So we say yes. They're always multiplying by the same thing. Let's do an example. Pause the video. All right, we're going to graph this function y equals negative 3 to the x. Remember, that's negative 1 times 3 to the x power. So I'm going to start plotting a few points. I'm going to do negative 2. Let's do negative 1, 0, 1, and 2. That'll give me a good curve. So if you plug in negative 2, you get negative 3 to the negative 2 power. 3 to the negative power is going to be 1 over 9. And that negative on the outside means I have negative 1 over 9. So negative 1 over 9 is going to be at negative 2 and just under that, a little bit under. So I'll put a point there. For the next one, negative 3 to the negative 1 power is going to be negative 1/3. That's going to be close, but not as close as the other one. Next one, negative 3 to the 0 power will be negative 1. So I'll put it at negative 1. Negative 3 to the 1 power will be negative 3. So at 1, negative 3. I'm going to label that. I'm going to label this other one too. 0, negative 1. And 2 is going to be negative 3 squared will be negative 9. So at 2 it goes down to negative 9, which is over here. And I can see I have an exponential curve going right there, so I'm going to try graphing that. I see that there's going to be a asymptote. You know what? I'm going to draw straight lines like this. That'll look so much better. So there's my asymptote. And now I can draw that curve. So, oh boy, that's no good. I can do much better than this. And you try to draw your exponential curve as best as possible. Something like that. Put arrowheads on. And there you go. That's what I'm looking for. Try next one. Okay, does this table represent an exponential function? Every time you increase x by 1, and we're going up 1 every time, you have to multiply the y by the same common ratio. So 2 to 4, we're multiplying times 2, because 2 times 2 is 4. And 4 to 6, well, what's that multiplying by? That's actually multiplying by 3/2, or 1.5. That's a different common ratio here. So is this an exponential function? No. We are adding by the same thing. It is going plus 2 every time, plus 2, plus 2. That makes it a linear function, not exponential. So the answer is no. That's it.